Hello everyone, my name is Sonali and I am a sustainability consultant based out of Delhi, India. I am a lead AP in building design and construction, and today we are going to learn about energy and atmosphere category under LEED V4. This is actually second part of the energy and atmosphere category. If you want to check out first part, you can go to the playlist in our channel. So let's get started. So just a recap of the part 1 that we had done. So in part 1 we talked about energy baseline standard. So we talked about what is the standard that is used to establish the baseline and how is it dictated. We also talked about some energy conservation strategies which were to reduce building footprint, to provide passive design strategies, to provide high performance building envelope, and to conduct commissioning strategies, and to provide energy sub-metering and automated building controls. So today we are going to be focusing on some increased energy efficiency measures apart from the one that we discussed in part 1, and renewable energy and carbon offsets, and the use of harmful refrigerants and their elimination. So in terms of LEED, we have some prerequisites and credits, as we have already discussed in all of our videos. So in this video, we'll be focusing on some strategies which will contribute to minimum and optimize energy performance for 18 points. We'll talk about fundamental refrigerant management and enhanced refrigerant management. And we'll discuss demand response, renewable energy production, and green power and carbon offsets. So coming to the increased energy efficiency measures, so the first category here is participating in a demand response program. So this strategy actually can help you gain points in optimize energy performance as well as demand response, because it helps you reduce the energy consumption of the building, and it also gets you point in the category in the credit demand response, where the projects can get points for participating in a demand response program in their region or their cities. So let's understand what demand response is. So we know that our energy demand throughout the day is not constant. It's continuously changing throughout the day based on the processes and different kind of activities that are happening. So and the demand and the energy supply is actually constant. So there are some peak hours during the day where the where the energy demand is actually higher than the supply. So to accommodate this, projects can actually change their energy or shift their energy to a different energy source, or actually reduce their energy at this time, so there's less burden on the energy grid or the electricity grid. And this program actually is provided by the utility suppliers in the region, where the projects can tie up or participate in these programs, and then they can implement those strategies to shift their energy demands during the peak hours. So demand response is nothing but a change in electricity consumption by the consumers, such as commercial and industrial businesses, to help them keep the supply and demand of electricity in balance. So just to understand it from an example, the supply and demand should be equal. So too much supply can cause brownouts and blackouts, or too little supply can cause the power plants sitting idle, and that could cost a lot of money to the utility companies. So it is important that we we have this balance, and that's where demand response programs helps us to achieve this. So here are some strategies that can help you participate in this, or that can actually help you reduce your energy consumption or shift it during the peak hours. So the first would be reducing your lighting levels or adjusting your space temperature set points, which will reduce your energy consumption. Turning down or turning off your non-essential loads such as fountains, decorative features, or video displays. And postponing any energy intensive activities such as running your dishwashers, laundry machines to a later period when the peak demand is gone. So the projects can earn points in this category by two ways. Either they participate in a demand response program through the strategies that I've just discussed, or any others that contribute to the same cause, or they can, if the demand response program is not available in their city, they equip their buildings or install infrastructure to participate in a future demand response program. So they'll get point based on which of these they have opted. So the next strategy in terms of increased energy efficiency is energy benchmarking. So energy benchmarking is basically comparing the data set to other buildings or other buildings in the region of similar typology, so that it can be compared and necessary implementations or energy conservation measures can be implemented to further reduce the energy consumption. So this is basically done through a tool, an online tool, which is called Energy Star Portfolio Manager. This is from EPA, US Energy Protection Agency. And the basis of performance on this platform is it tracks the building relative to other green buildings in the region, or it tracks the performance of the building to its own past performance. So you input your data in this portal for energy and water, and it will track compared to the other buildings in the region. So in this you have two types of scores. One is the energy score and one is the water score. Both of them is dependent on the data that you input, which will come from your utility bills for both of them, and it gives out a score of 1 to 100 based on that. So it's similar to any tracking device that you have, like your smartwatch. So like it monitors your continuous levels of different parameters. Similarly, this also monitors your building performance based on these parameters, and it gives out scores, and a score of 50 is considered a median performance score, and a score of 75 or above is considered a top performer. And actually this one is eligible for Energy Star certification if they want to go for that. So this is how the dashboard of Energy Star Portfolio Manager looks like. So different property managers can actually list a bunch of their properties here, not just one, and they can track different properties at the same time or different buildings at the same time to track their performance if they have implemented any conservation measures and they want to see how much it is performing based on those measures. So the next strategy here is to utilize high performance building system. So high performance building systems here refer to any systems installed in the building that will make the building more efficient in terms of its energy use. So it may be twice as costly as the inefficient systems, but it is going to save the owner money through its reduced energy bills, and it is going to reduce the overall greenhouse gas emissions during its operations. So to understand that, or to make an informed decision, it is important to conduct a life cycle costing based on what systems you're opting. So life cycle costing would be to just analyze the capital cost of the system and then do an analysis based on the savings in the operational cost. So this will give you a comparison of the payback period of the efficient system that you're installing, and it can help us make an informed decision very early in the stage. So this is an example of life cycle costing of 4 HVAC systems, and you can see here there's capital cost, there's maintenance cost here, and also the life cycle cost, which is actually the payback period of each of the HVAC systems. So a similar approach can be taken for all the projects at a very initial stage, which can help them choose between different systems proposed for the project. So another energy efficiency strategy would be installing or having high efficiency appliances. So when you're at home, you might see a lot of appliances in your home with different star ratings. So it could be in your washing machine, it could be on your microwave, it could be in your ACs. So those star ratings are actually the efficiency or the rating provided based on the efficiency of the appliance. So higher the rating, or if there's a star there, then it is more efficient than the standard appliances. So for example, in international, I think Energy Star is more prevalent, but in India we have BE star rated appliances, which varies from 1 star to 5 star in the ascending order of the efficiency. So it can actually save up to 10 to 15% less energy than the standard appliances, and it can help you reduce your energy cost through your bills. Another important strategy is to implement energy model. While we did discuss about the baseline studies in the part 1, so those baseline studies are actually important when you're doing an energy model. So this energy model should ideally be done in the concept or schematic design of the building, and the simulation actually shows you how well or how will the building perform in varying conditions, and based on that you can optimize the design to achieve the desired energy targets. So this is, like I said, this is done in the schematic design stage, and it actually helps you reduce your loads very early in the design. So it's important that we do it as early as possible in the design stages. Now that we have discussed the strategies to increase the energy efficiency, let's move on to how we can change the source of our energy. So the strategies we discussed, they are mostly looking at reducing your energy consumption, but here we are discussing how we can change the energy source. We can shift to renewable energy sources for the buildings. So this is the credit is called renewable energy production, which consists of 3 points. And if we understand the current energy mix here, so the current energy mix is of coal, petroleum, renewable, nuclear and natural gas. So if you see here, only 13% of the current energy consumption is through renewable energy, and rest of all is based on coal, petroleum, natural gas and nuclear. So if you see here, most of the energy sources that we have today that are fossil fuels, they have a very high CO2 emissions, and in order to change that, we need to shift to renewable energy sources. So to shift to renewable energy, there are various forms of renewable energy that we can consider when we are trying to offset our energy source. So the intent here is to reduce the building's carbon footprint, and renewable energy is a key strategy. And this is basically to offset the fossil fuel usage, thereby lessening the amount of CO2 emissions and other greenhouse gases released into the environment. So we have various forms: solar, geothermal, wind, biomass and hydroelectric, and this is the current energy mix based on the US EPA data. So let's talk about each of them briefly. So solar power systems are actually available in 2 forms. One is through solar PV panels that goes on the roof, and the other is solar thermal systems. So solar panels are used to produce energy through solar power, and the solar thermal systems are actually used to heat your water systems or heat for solar water heating. This is helpful when we want to change your solar water heating from electricity to solar directly. So that's a good measure to implement in the building. And both of these types can be found on roof level as well as ground arrays. Geothermal energy is actually the residual heat energy from earth, which can provide an energy efficient way to provide electricity, heat water for use or heat a building. So this is actually done through a very tedious process. So wind energy has become very popular once the government policies and incentives have been in place. But this is a bit challenging when we have a smaller site, and because this requires a huge area and they have to be at a distance from homes, roads and other buildings. So they do have some challenges in terms of site, but they are a very efficient way, and we can see that 29% of the current renewable energy usage is being done by the wind energy. Biomass. So bioenergy is actually energy produced from processing different forms of waste. This includes your biomass, your biofuel or biogas. So this comes from all kinds of organic waste in terms of plants, your wood or wood products or wood waste. They are the largest sources of biomass. So when we are able to do that through the operational waste of the project, then it actually becomes a synergy between the two credits, which is energy and atmosphere and material and resources, because there we are diverting our waste. So it's a win-win situation for both the categories. You're able to divert through the waste to energy plants on your site. Hydropower or hydroelectric power. So hydropower is energy produced from the force of moving water. So hydropower output can vary due to water sustainability practices and rainfall management. And most hydropower projects are done at a very large scale. While projects can use a low impact hydroelectricity plant on their site by using like a small river or small streams, so that can be considered when they are going for renewable energy production. So renewable energy, the terms that we discussed now, they were all on-site renewable energy, but there is also a way to purchase off-site energy, renewable energy. So this is a second path where the building wants to balance their energy portfolio. So there are some terms that you need to understand when we are purchasing off-site energy. So the first would be green power. Green power is the renewable energy that is purchased from the utility supplier. So most utilities, they sell renewable energy to consumers somewhere else in the region. So let's say they're producing energy in a particular region, then they sell it to a different region where the energy supply is less or not reliable. And projects will actually get points if they engage in a contract of minimum 5 years with the utility companies. And we also have RECs, which are renewable energy certificates. They are another form of green power. They are a tradable commodity sold in an open market, produced of renewable energy. So, for example, somebody is producing some amount of renewable energy. They can actually put that in an open market, and somebody else can buy the rights of those through REC's renewable energy certificates to offset their energy consumption. So one REC here represents 1 megawatt hour of energy produced, renewable energy produced. And all of this is actually done through Green E certification program. So this program is a third-party rating system for renewable energy, and this is run by Center for Resource Solutions. So under LEED V4, all green power and all RECs, they must be certified by the Green E certification program. Or if there are any local equivalents, then that is also acceptable in case-to-case basis. So how RECs work is, currently you have a fossil fuel generator which gives power to the transmission to the utility providers, and then that gives you power to run your homes. But if there is, let's say, a renewable energy power generated, they can sell you through these RECs. Instead of giving it to the utility companies, they can sell it to you directly as RECs, like one REC or two RECs, and this is again certified through these third-party agencies like Green E Energy certifications. And there are also some terms called carbon offsets. So carbon offset is actually, besides RECs, carbon offsets are basically when you're offsetting your carbon emissions. This doesn't necessarily include energy. So this could be your emissions, offsetting your emissions through reforestation or reducing deforestation, or for carbon credits or methane projects. So for example, if somebody is offsetting their carbon through planting more trees, then it is possible to convert that into a certificate in terms of carbon credits or something else, and that can be bought by the project owner which wants to offset their energy through these carbon credits or carbon offsets. So the next section is refrigerant management, and this contributes to credits and prerequisites fundamental and enhanced refrigerant management for 1 point. So what is a refrigerant? So refrigerant is actually a fluid that that is used in any refrigeration system. And what it does is it absorbs heat to change from liquid to vapor, and it gives up heat to change from vapor to a liquid. And in this process, it releases a lot of carbon emissions into the atmosphere. And it depends on what refrigerants you're using, but mostly CFCs and HCFC refrigerants, they have a very high ozone depleting potential and a global warming potential. So that those refrigerants are actually not advisable to use, and we are shifting to more eco-friendly refrigerants or refrigerants with low global warming potential and zero ozone depleting potential. So if you see here, CFC, HCFC and HFC based refrigerants, they are harmful and they contain higher amounts of the ODP and GWP as compared to the natural refrigerants or the newer refrigerants with lower values. So the Montreal Protocol, we need to discuss, because that was actually an international treaty where 197 countries agreed to eliminating the use of harmful refrigerants that deplete the ozone layer. And this was done in 1987, and they banned the CFCs, and there was a plan to phase out HCFCs by 2030 so that we can eliminate the refrigerants with ozone depleting potential. So if you see this table, this is actually the refrigerants and their ODP and their GWP content in that, and then based on that there's a scale given to it. So if you see here, all CFC based refrigerants, they have a high ODP and a high GWP. All HCFC based refrigerants have a high ODP and a high GWP, but in some cases it does have a lower to medium GWP as well. And in HCFC, the ODP content is 0, but the GWP or the global warming potential is still high. We are able to replace all the HCFC and CFC based refrigerants, but we are still trying to phase out other refrigerants which have a lower GWP as well. If you look at other refrigerants here, the natural ones, this one, if you see, has a 0 ODP and also has a global warming potential which is less than 50 tons CO2. So these are the preferred ones in terms of the refrigerant management of our systems. So now we come to the last section of the video, which talks about how we can enhance our ongoing energy performance or how we can track it. So why this is important is that the measurement and verification of the building's ongoing energy performance is what keeps the building sustainable. While we have designed it to a certain threshold or to a certain target, we can only know the actual performance when we are doing the proper measurements and verification. So a LEED certified new building is only as green as the owners and occupants keep it. So the first thing that is important in terms of the ongoing energy performance is the tracking of the performance. So if you see, we discussed the Energy Star Portfolio Manager. That is also one of the ways where you can track your building's performance. And tracking your performance can be done in terms of your energy, water, and also you may track your waste generation as well. And this is a way where you can validate your project's anticipated or projected performance. There are some other ways where you can do that. So one of them would be to have a owner project requirement, that is an OPR. So the OPR forms the basis from which all design, construction, acceptable and operational decisions are made. And OPRs should have all green energy goals for continuous benchmarking. So this is important, and this has to be developed even before the design is commencing. And then the next step is training the building managers, ensuring that the managers are trained and knowledgeable in running the building as per the OPR, as well as in sustainable operations and management is critical. So this is important when we are wanting to maintain and improve our performance over its lifetime. So the next strategy to improve ongoing energy performance is to provide incentives for building occupants. So whether it's your tenants or occupants or employees, so they have a very significant effect or impact on the use and performance of the building. only if they are informed of the performance, they can contribute more, as they would feel more involved and responsible for the energy performance. So it's important that they are updated or they are incentivized. If they, let's say if they do something, if they're able to reduce their energy consumption bill by something or the other, they'll get incentivized through some subsidies or something. So that's one way of reducing your ongoing energy performance. The other way is preventive maintenance. So tuning up your systems yearly, checking for inefficiencies, for leaks or cracks. This should be part of all the systems. It should be done on a yearly basis to actually check how the systems are working and what are the missing elements in the system. So that is the end of all the strategies for energy and atmosphere category part 2. And just to summarize, we discussed energy efficiency strategies, which is demand response program, energy benchmarking through Energy Star portfolio, utilize high performance building systems, high efficiency appliances, and implementing energy modeling or analysis. We also talked about renewable energy and carbon offsets. We discussed renewable energy in terms of solar, wind, hydroelectric, geothermal, biomass, and we discussed carbon offsets in terms of green power, RECs, which is certified through Green E certifications. So one important thing is the Montreal Protocol 1987. So we already discussed that this was important in terms of phasing out or banning the CFCs and then phasing out the HCFCs. So this is an important treaty that was signed by 197 countries. This is to remember in terms of your exam. So let's move to the Q&A part of the video. So the first question is, green power, carbon offsets and RECs must be certified by which program to qualify for points in EA category, green power and carbon offsets? A. Center for Resource Solutions, B. Energy Star, C. Green E certification program, D. WaterSense, and E. DOE State Energy Program. So you can pause and check what you think the right answer is. So the right answer is Green E certification program. We had just discussed this in the summary as well. Moving to question 2. APA's Energy Star Portfolio Manager is an interactive online management tool that supports the tracking and assessment of energy and water consumption. In Portfolio Manager, what score represents average building performance and what score or above means that the building is a top performance or top performer? A. Silver and platinum, B. 0, 100, C. Certified gold, D. 25, 50, E. 50, 75. You can see and check what you think is the right answer. So if you see here, it's asking us what score represents the average answer. So you can actually eliminate A and C based on that because they're asking for score. And if you see, the score is for average and then top performer. So we saw in the energy portfolio manager slide that 50 is the average building performance and 75 is the top performance, 75 or above. So that's the correct answer. Question 3 is that the Montreal Protocol banned the production of which refrigerant and is phasing out which other refrigerant? So the answer for this one is B, CFCs and HCFC. So we have just discussed this. HCFC has been banned and CFCs has been banned and HCFCs have been phased out, are planned to be phased out by 2030. So that's all for today and I hope to see you in the next videos. Thank you so much.